Ladies and gentlemen, we will start now the second lecture in Introduction module. We can call this lecture Fundamentals of the Statistics. The following topics will be covered: Fundamentals of the Statistics, Process statistical analysis, Calculate the outlier using standard normal probabilities tables, Calculate the outlier using Excel, Exercise on the statistical analysis. Two main statistical methods are used in data analysis: descriptive statistics and inferential statistics. Descriptive statistics are methods for organizing and summarizing data. For example, tables or graphs are used to organize data, and descriptive values, such as the average score, are used to summarize data. A descriptive value for a population is called a parameter, while a descriptive value for a sample is called a statistic. Inferential statistics are methods for using sample data to make general conclusions, inferences, about populations. Because a sample is typically only a part of the whole population, sample data provide only limited information about the population. As a result, sample statistics are generally imperfect representatives of the corresponding population parameters. The four basic words of statistics are: population, all the members of a group about which you want to draw a conclusion; sample, the part of the population selected for analysis; parameter, a numerical measure that describes a characteristic of a population; statistic, a numerical measure that describes a characteristic of a sample. The sample mean is the average, and it is computed as the sum of all the observed outcomes from the sample divided by the total number of events. The standard deviation can be thought of measuring how far the data values lie from the mean. To calculate the standard deviation, please follow the steps: find the mean, find the deviation from the mean for each data value, square each of the deviations, find the sum of all of these squared deviations, average these by dividing by the number of observations, minus 1. Return to the units of the problem by taking the square root. The histogram is an approximate representation of the distribution of categorical data. To construct a histogram, the first step is to bin the range of values. That is, divide the entire range of values into a series of intervals, and then count how many values fall into each interval. Example: to calculate the mean value and the standard deviation, a sample of 9 students who attend community services at least once a week. First, calculate the mean, it is 5. Then, calculate the variance, as described in the previous slide, the variance is 3. Take the root mean square of the variance to calculate the standard deviation, 1.7. To generate descriptive statistics report, execute the following steps. On the Data tab, in the Analysis group, click Data Analysis. Select Descriptive Statistics and click OK. Select the input range. Select Cell as the output range. Make sure Summary Statistics is checked. For example, a pharmaceutical company fills bottles with a saline solution. They measured the salt concentration of a sample of 50 bottles. To generate the descriptive statistics report for these data, please pause the lecture and enter the data in Excel and follow the previous steps, then click OK to see the result. Here is the descriptive statistics report for the data of the bottles with the saline solution. To create a histogram using data analysis, you need to create the data intervals in which we want to find the data frequency. These are called bins. The bins would be the marks intervals. You need to specify these bins separately in an additional column as shown. Then, click the Data tab. In the Analysis group, click on Data Analysis. In the Data Analysis dialog box, select Histogram from the list. Click OK. In the Histogram dialog box, select the input range, all the marks in our example. Select the bin range. Leave the Labels checkbox unchecked. Specify the output range if you want to get the histogram in the same worksheet. Else, choose New Worksheet or Workbook option to get it in a separate worksheet or workbook. Select the entire dataset. Click the Insert tab. In the Charts group, click on the 2D column option. Modify the properties of the chart. During the course, we will learn how to generate the histogram chart using Sigma XL and Minitab. Please download the educational video from the resources Process Statistical Analysis.mp4. Please check the histogram, mean value, and standard deviation for our sample of 50 pieces. If a larger sample, for example, 5,000 is a reasonable number, the histogram now has a much more regular and symmetrical shape. If you take an even larger sample, say 20,000, you will see that the histogram is much same shape, although the y-axis scale is different. The larger the sample, the less ragged the shape, and if you take a sufficiently large sample, it will look like this. Let's check different shapes of histogram, depending on the location and spread of data. For A, most of data were on target, with very little variation from target. For B, some of data were on target, however, many others were dispersed away from the target. For C, most of the data were close together, however, they are located off the target by significant amount. For D, the data were off target and widely dispersed away. Is the process within the specification limits? We have two specification limits, the upper specification limit and the lower specification limit. The histogram shows not only whether the process was within the specification limits, but also how close to the target. The process should be checked in a selected time interval in order to check the process stability. The process histogram differs from day to another. There are common histogram shapes: skewed or non-symmetrical, discontinued, symmetrical or mirror-imaged. The shape may shows that something is wrong. For example, data from different sources were mixed. Different measuring devices were used. Operational definitions were not clear. Normally, further analysis is required to find the causes of uncommon shape. During the course, we will learn the tools and techniques to measure and analyze the data and find the source of the problem in order to solve it. The normal distribution is a type of continuous probability distribution for a real-valued random variable. The general form of its probability density function is shown. The parameter mu is the mean or expectation of the distribution, and also its median and mode, while the parameter sigma is its standard deviation. Normal distributions are important in statistics, and are often used in the natural and social sciences to represent real-valued random variables whose distributions are not known. Their importance is partly due to the central limit theorem. Skewness is a measure of symmetry, or more precisely, the lack of symmetry. A distribution, or data set, is symmetric if it looks the same to the left and right of the center point. The skewness for a normal distribution is 0, and any symmetric data should have a skewness near 0. Negative values for the skewness indicate data that are skewed left, and positive values for the skewness indicate data that are skewed right. By skewed left, we mean that the left tail is long relative to the right tail. Similarly, skewed right means that the right tail is long relative to the left tail. Kurtosis is a measure of whether the data are heavy-tailed or light-tailed relative to a normal distribution. That is, data sets with high kurtosis tend to have heavy tails, or outliers. Data sets with low kurtosis tend to have light tails, or lack of outliers. A uniform distribution would be the extreme case. To access the normal distribution probability calculator in Sigma Excel, click Sigma Excel, then Templates and Calculators, then Probability Distribution Calculators, then Normal. The template gives the following default example by entering the mean, standard deviation, lower limit, and upper limit. You can check different probabilities of interest according to the required analysis. Please download the educational video from the resources normaldistribution.mp4 for detailed steps for the normal distribution probability calculations using Excel and Sigma Excel. To understand the binomial distribution, please consider the following random experiments and random variables. First experiment, flip a coin 10 times. Let X number of heads obtained. Second experiment, a worn machine tool produces 1% defective parts. Let X number of defective parts in the next 25 parts produced. Each of these random experiments can be thought of as consisting of a series of repeated random trials. 10 flips of the coin in experiment 1, the production of 25 parts in experiment 2. The outcome from each trial either meets the criterion that X counts, or it does not. Consequently, each trial can be summarized as resulting in either a success or a failure. The terms success and failure are just labels. We can just as well use A and B, or 0, or 1. What is binomial distribution? In probability theory and statistics, the binomial distribution with parameters n and p is the discrete probability distribution of the number of successes in a sequence of n independent experiments, each with its own Boolean-valued outcome, success, with probability p, or failure, with probability q equal 1 minus p. A single success-failure experiment is also called a Bernoulli trial, or Bernoulli experiment, and a sequence of outcomes is called a Bernoulli process. The probability of getting exactly k successes in n independent Bernoulli trials is given by the probability mass function. The mean value and the variance of the distribution are shown, mu equal to n times p, and variance equal to n times p times 1 minus p. Now, we will check different binomial distribution for different n and p. The first plot shows the f of x for p equal to 0.5 and n equal to 20. The second plot shows the f of x for p equal to 0.1 and 0.9, while n equal to 10. Let us make an exercise to understand the binomial distribution. Each sample of water has a 10% chance of containing a particular organic pollutant. Assume that the samples are independent with regard to the presence of the pollutant. 1. Find the probability that, in the next 18 samples, exactly 2 contain the pollutant. 2. Determine the probability that at least 4 samples contain the pollutant. 3. Find the mean and variance of a geometric random variable. Please pause the lecture and perform the exercise. To solve the exercise, let X be the number of samples that contain the pollutant in the next 18 samples analyzed. Then, x is a binomial random variable with p equal to 0.1 and n equal to 18. Therefore, p of x equal to 2 is 0.284. The mu is 1.8, and the variance is 1.62. To access the binomial distribution probability calculator in Sigma Excel, click Analyze, then Templates and Calculators, then Probability Distribution Calculators, then Binomial. The template gives the following default example. By entering the number of trials, event probability, and number of events in n trials, you can check different probabilities of interest according to the required analysis. To access the binomial distribution probability calculator in Minitab, click Calc, then Probability Distribution, then Binomial. Enter number of trials, event probability, and input column, which contains the x value, then press OK. You can find now the cumulative distribution function value for specific n, and p, and x. Please perform the following activity, and send the outcome by email, for assessment. You can find the activities in the course material PDF file, or in the resources. In order to understand the Poisson distribution, consider the transmission of n bits over a digital communication channel. Let the random variable x equal the number of bits in error. When the probability that a bit is in error is constant, and the transmissions are independent, then x has a binomial distribution. Let p denote the probability that a bit is in error. And let lambda is equal to p times n. Then e of x is equal to p times n, and then it is equal to lambda. The probability function of Poisson distribution is shown. Now, suppose that the number of bits transmitted increases, and the probability of an error decreases, exactly enough that Pn remains equal to a constant. That is, n increases and p decreases accordingly, such that e of x remains constant. Then, with some work, it can be shown that the probability function can be as shown. Also, because the number of bits transmitted tends to infinity, the number of errors can equal any non-negative integer. Therefore, the range of x is the integers from 0 to infinity. The derivation of the mean and variance of a Poisson random variable. Mean is equal to the variance, equal to lambda. Now, we will check different Poisson distribution for different lambda. For lambda equal to 0.1, 2, and 5. Let us make an exercise to understand the Poisson distribution. Contamination is a problem in the manufacture of optical storage disks. The number of particles of contamination that occur on an optical disk has a Poisson distribution, and the average number of particles per square centimeter of media surface is 0.1. The area of a disk under study is 100 square centimeter. Find the probability that 12 particles occur in the area of a disk under study. Please pause the lecture and perform the exercise. Let x denote the number of particles in the area of a disk under study. Because the mean number of particles is 0.1 particles per square centimeter, lambda is equal to 10 particles. Therefore, p of x equal to 12 is 0.095. To access the Poisson distribution probability calculator in Sigma Excel, click Analyze, then Templates and Calculators, then probability distribution calculators, then Poisson. The template gives the following example by entering the mean and number of occurrences. You can check different probabilities of interest according to the required analysis. To access the Poisson distribution probability calculator in Minitab, click Calc, then Probability Distribution, then Poisson. Enter the mean and input column, which contains the x value, then press OK. You can find now the cumulative distribution function value for specific mean and x. Please download the educational video from the resources Binomial and Poisson distribution.mp4 for detailed steps for the binomial and Poisson distribution probability calculations using Excel and Sigma Excel. Please perform the following activity and send the outcome by email for assessment. You can find the activities in the course material PDF file or in the resources. Thank you, and see you in the second part of the second lecture of Introduction module.